Right, welcome. We're going to be looking at this rather tricky recognising graphs and factors question from Dr. Frost. And it's taken from the IGCSE Further maths paper. So really it's for all the level 9 wannabes out there. Here's a sketch of the cubic function y equals f of x. And we can see it crosses at -5, 0 and 3. And we want to use this sketch to write down 3 linear factors of x. Well, the fact that it only tells you -5, the origin, and 3 gives you a bit of a hint of what the answer might be, because there's 3 things there and there's 3 linear factors. But let's look at something a little bit more simple. Let's look at y equals x squared plus 5x plus 6. And we notice that it crosses at -3 and 2. And the reason why I've drawn this, y equals x plus 3, x plus 2, is because x plus 3, x plus 2 is just this factorized. Okay, I've just factorized that. If I just hide this graph for a second and show this graph, we see it crosses in exactly the same places. And what we're doing here is actually, if you think about it, all the way along this line here, y equals 0. Yep, the y value is 0. There's 1, there's 2, there's 3, there's -1, there's 0. So we're actually solving 0 equals x plus 3 times x plus 2 all the way along this line. Now, if these two things tied together give you 0, either the x plus 3 must equal 0, in which case x equals -3, or the x plus 2 must equal 0, in which case x equals -2. So therefore, we can see that when you've got two numbers times together to give you 0, one of them must be 0, or the other one must be 0. And if we solve each one, you can see the two places where we cross the axes. So let's just get rid of all of that and just look at another graph. We're going to look at this cubic here. And what we got here, we got a cubic crossing at -3, -2, and 0. And if you notice, here are the values. You're going to remember, if you're going to have 0 equals x times x plus 3 times x plus 2, then either this or this or this must equal 0. So we have x equals 0 is one answer. There it is. Or x plus 3 equals 0, which gives us x equals -3. And there it is. And we've got x plus 2 equals 0. So x equals -2. And there's that one. So we can see that these are our linear factors. Now, the reason why they're called linear factors is if you were to draw y equals one of them, let's say we draw y equals x plus 2, we get a straight line. Y equals x plus 2 looks something like this. It's a straight line. It goes through there and it goes through y value at 2. Okay, and all of these are going to be straight lines. So let's just get rid of all of that and go back to our question. So we can see here that it crosses -5, 0, and 3. So our linear factors are going to be x plus 5, because if you solve that equals to 0, you get x plus 5 equals 0, x equals -5. We're going backwards. So that's one linear factor. And therefore, another linear factor is going to be x, well, we can say -0, which is just equal to x. So there's another linear factor. And then you've got x minus this value. X minus 3 is our other linear factor. Okay. So, because if we solve that to equal to 0, if we solve x minus 3 equals 0, we can see that x equals 3, and that's where it crosses. So our 3 linear factors are x, x minus 3, x plus 5. Now, if we were to times them together, they may give us this function, they may not. Okay, but it all depends on whether it's a multiple of these things or not. But it will definitely cross at these points. So there we go. Wherever we have an intersection in the x-axis, then we must have x minus that value to give us a linear factor.